have a phone number. Mechanical engineering design. Jail. So I have his number. So I think I need somebody to cater on behalf of me and should okay, Sam will take your class later maybe on Tuesday. When is it scheduled? The next class on Tuesday? Anybody? Do you know when is the next class? So anybody's please gather some number we need actually. You are from different departments, we don't know anybody who should we contact in the meantime, anything like that. I think we need a number. Okay.
Sir, sir, yes, sir, from 4:30 to 5:30.
Which one?
Sir, I couldn't hear you, sir. Actually, the connection just was breaking, sir.
Yeah, can you hear me now?
Can you, sir? Yes, sir. Yes, sir. Sir, the connectivity is a bit lagging, sir, sometimes.
Yeah, I cannot help it.
Yeah,
You
it's clear now, sir. It's clear now, sir.
so no, no, yeah, you Tomojit, I need somebody to cater on behalf of us. So if we can contact you so that you can communicate all your friends with all your friends. So in that way, it will be
Okay, sir.
easy.
Okay, sir.
Okay.
Surely, sir. Okay, sir. Okay, sir.
So I will post my number in the chat box so that you can save all those things. Okay.
Okay, sir. Okay, sir.
You save it and accordingly.
Yes, sir. Surely.
And okay, so as per your syllabus goes, so myself and Sudeshna will both be taking classes consecutively. So it's a huge syllabus. So I'll be taking the first class, then followed by Sudeshna, then followed by me. I'll be taking your classes on Saturday, and Sudeshna maybe on Tuesday. So okay, from today itself, how many of you are in the class? Now is 41. How many of you are there? More than 100? Most of you are from mechanical engineering or some other background also?
Sir, we don't, sir, like the actually the exact
Okay, okay.
figures.
And then
Technical,
it's okay.
there is a bulk of students.
Fine. So what I'll be doing, I'm thinking of starting colloid first. Okay, the basic things of colloid. So once you understand these things, then the other things, the numerical part of those will be easier for you. Unless, can you hear me or my sound is breaking?
So it's clear, sir.
Okay, and rest, please mute yourself. Okay. Once you have any questions, then you can ask me out. Okay. First, what do you mean by colloid? Okay, Tomojit, what do you mean by colloid? It should be interactive session. Nothing to take it very seriously. Do you have any idea what do you mean by colloid?
So it's a kind of suspension.
It's a kind of suspension. So, what is the difference of a colloid from a solution? Solution is also a kind of suspension kind of thing. So, is there any difference of the between of a colloid from a solution?
Sir,
So the size of the
Whenever
কে বলছো বলো?
deep deep ball,
so the size of the like suspended particles that might differ in a solution, it's very
Right. Size of
less,
suspended
and
particles. What is the size of the suspended particle? Do you know, Deep? What is the size of the suspended particle
no
in
sir,
case
no
of
sir, no
colloid?
sir, I don't know the range.
So it is ranging between. I think you can note it down. You can note these down what the things are. And the thing is that you cannot record, but because our official ID is creating some problems. If you can record my talk also, but officially you cannot do that. But you can see I can join it from Gmail because there are some problems in the official ID, so I cannot do the recording part. From your point of view, you can do it by otherwise you can note it down. Okay. Later, once I will make some notes and I will share with you with the class also. Okay. But right now I do not have anything. So once the class starts, when it's going on, then I can share you with the things, with the notes, lecture notes. Okay. So basically, colloid, the dimension of the particle is ranges between a nanometer to a micrometer. A nanometer to a micrometer. Okay. And basically, what is the basic difference between a colloid from a solution? Okay. A solution, if you take a parchment or a filter paper on top of a filtration assembly, when you put a sugar solution into that, what you can see, can you distinguish sugar from the solution? No. Or a salt from the solution? No. It passes through. That is the homogeneous solution. That is the basic homogeneity. But in case of colloid, it won't pass through. Basic things, it won't pass through. Okay. So thing is that there are different kind of
yes, sir.
colloid available. হ্যাঁ তমজিৎ কিছু বলছিলে? No, right? Okay. Different kind of these kinds colloids are available. First, the dispersed phase and the medium. Depending on the dispersed phase, the medium, it has been categorized into different category. If the dispersed phase is liquid and the medium is gas, then the colloid is called aerosol. It's called liquid aerosol. Okay. Example, what I told, if the dispersed phase is liquid and dispersing medium is gas, then it's called liquid aerosol. Can you tell me any example of liquid aerosol? Use it frequently.
Sir, একটু repeat করবেন কি বল?
You write it down. Okay. If the
Yes, sir.
dispersed phase is liquid, there are two kind of phase. One is dispersing medium and another is dispersed phase in case of colloid. In case of solution is also it is true, but what happens in the solution, it is homogeneous solution, it completely dissolve in the dispersed phase. But for colloid it is not true. For colloid it is not true. Some kind of colloid the dispersion is more readily available. Some kind of colloids you need to put some energy to get it dispersed in the dispersion medium. Okay. So there are different kinds of colloid is available and it has been categorized depending upon the dispersed phase and the dispersing medium. Okay. When the dispersed phase is liquid, it may be water, it may be alcohol, it may be some kind of organic liquid, non-organic, it may be non-polar liquid, anything. When the dispersed phase is liquid, medium is what is called, it is called aerosol. Example, do you have an example in mind for the liquid aerosol? Let's say or cloud. What is that?
So that's a dispersion of dust particles in air, sir, basically. I mean, containing water vapor, obviously, sir.
No. Dispersion of droplet in dispersion of what?
Sorry, sir, droplets.
That is the dispersion of liquid in the gas.
Yes.
Right? So that is the fog, that is the cloud. আরেকটা জিনিস হয়, you have the যেটা তোমরা হেয়ার স্প্রে ইউজ করো, liquid hair, those are liquid. Okay. second time, Shomojit Roy is telling you are not completely audible. Is it? You are not. My voice is breaking because
Yes, sir.
this is the.
Sometimes it's breaking, sir. Yes, sir.
So
Yes,
কি
sir,
হচ্ছে বলো তো,
sometimes.
প্লিজ আই ক্যানট হেল্প ইট। আমি কিছু করতে পারবো না যে হোয়াট আই এম
স্যার
ডেলিভারিং। এবার
আপনি
যদি
স্যার হ্যালো
খারাপ
স্যার
থাকে, হ্যাঁ
স্যার
বলো।
স্যার আপনি একবার রিজয়েন করে দেখুন তো।
আমি আরেকবার করবো রিজয়েন, ওয়েট। শুনতে পাচ্ছ?
Yes,
Yes,
sir.
sir.
Now
Yes,
it's
sir.
better.
Okay. Second is type is if the dispersed phase is solid. Mind it. Dispersed phase is
স্যার
solid.
ফার্স্ট টাইপটা একবার বলবেন?
Dispersed phase.
ফার্স্ট
দুটো তো,
টাইপ
একটা dispersed phase, একটা dispersed medium. If the dispersed phase is solid and the dispersed medium is gas, it is called solid aerosol. যেটা that is a smoke or dust. Those are solid aerosols. Okay. Next is the dispersed phase is gas and the dispersion medium is liquid, then it is called foam. These are different kind of colloid I'm talking about. That liquid aerosol is a colloid, the solid aerosol is a colloid, foam is a colloid. Okay, foam যেরকম ধরো তোমরা সাবান গোলো, জল গোলো, that is the surfactant onto the solutions. Okay, fire extinguisher, those are foams. ঠিক আছে। The next is dispersed phase is liquid and the dispersion medium also liquid. ঠিক আছে, this is called emulsion. একটা এক্সাম্পল যাও, একটা এক্সাম্পল। if the dispersed phase is liquid and the dispersion medium is liquid.
Sir, milk.
Milk, right? Gaurav, mechanical.
Yes, sir.
Is milk a black body? Okay, going অন্যদিকে যাচ্ছি। Okay, if the dispersed phase is solid and dispersion medium is liquid, then you may name it sol or paste. This is the most commonly found this thing, your colloid in the industry. With us, we use this kind of colloid for the experimental purpose in the industry. So this is what, this is the when the dispersed phase is solid and dispersion medium is liquid. You may call it sol or paste, like gold sol, silver sol. Your toothpaste is also a colloid. Okay, like paint, okay, pigmented ink যেগুলো হয়, those all things are part of the colloid. এইভাবে বিভিন্ন রকমের there are lots of these things are যে different types of solid. If the dispersed phase is solid, solid, those are all colloid. Okay, like solid suspension, যেরকম ধরো carbon steel. You know carbon steel? So carbon in steel is a colloid where the dispersed phase is solid and also dispersion medium is also solid. These are different kinds of colloid where you can be getting in the industry level or even in the home or in the lab. Okay, so these are the category. You can categorize colloid into these things. So if you go on classification part, so classification of colloid can be made up kind of two type. One is lyophilic, another is lyophobic. Okay, so what is lyophilic? When the water is the dispersion medium, when the dispersion medium is water, আমি liquid বলেছি, when the dispersion medium liquid এর মধ্যে যদি water হয়, তাহলে then only comes the point of lyophilic and lyophobic. Okay, what is lyophilic? What do you mean by lyophilic colloids? Or you may tell it hydrophilic also.
So it has an philicity towards water or affinity towards water, so solution.
Affinity towards water. So how do you measure the affinity or hydrophilicity or hydrophobicity of the colloid? Any technique do you know?
No, sir.
Have you heard about the term contact angle?
Yes, sir.
Yes, sir.
Yes, sir.
So what is contact angle? Baba bolo.
The angle any liquid droplet makes with the horizontal surface over which it is placed.
Okay, fine, very good. So how the contact angle determines whether it is hydrophilic or hydrophobic?
Sir, actually, if it is less than 90 degree, then it is hydrophilic, and greater than 90 degree, then it is hydrophobic.
Very good. So greater
Sir,
than 90 degree, what do you mean by greater than 90 degree?
Greater than 90
Non-wetting.
degree means, yeah, non-wetting, like mercury light.
Mercury in glass.
Mercury in glass. Can you
Means-
cite one example how this hydrophobicity is being used to clean the surface? Very important.
Sir, actually, I think it will not indulge into any reactions with the surface.
This is
Rather, it
physical mode. This is definitely physical clean. That's what I'm asking. A huge industry is utilizing this super hydrophobicity. When the contact angle is greater than 140 degrees, the surface is called super hydrophobic surface. Okay. This concept is being utilized by a huge industry to clean the surface, to clean the glass by using this super hydrophobicity. To anybody from Kolkata? Anybody?
Yes.
Yes, sir. Yes.
Tomojit, South Cityর বাইরের গ্লাসটা দেখেছো? Have you seen that one?
Yes, sir. Yes, sir.
So that has been cleaned by super hydrophobicity using that mechanism. Okay, you never see it is sprinkling water onto top of that. They use that mechanism. Okay, there are some kind of models they've adopted. There's some kind of models to clean that surface out. Use the super
Sir,
hydrophobicity. Okay,
Sir, actually, water droplet on the lotus plant.
and that is hydrophobicity. That is hydrophobic.
Okay.
Completely hydrophobic. Okay, that is the idea. There are some kind of angles. I mean diverting from my topic. This is a huge topic. Super hydrophobicity and hydrophobicity. It's fine line between these two. What you are telling the droplet of water onto the lotus leaf, that is the hydrophobic in nature, but it can be made to super hydrophobic by applying some kind of surface modifications. Okay. So it can be made to super hydrophobic so that your dust particle cannot roll down with water and it's being taken care of. Okay, আমি বেরিয়ে যাচ্ছি লেকচার থেকে, এটা আলাদা টপিক, ঠিক আছে? So that is the lyophilic colloids and lyophobic colloids. What is the lyophilic colloid? Lyophilic colloid dispersion are formed easily, okay, by spontaneous dispersion of colloid particles in the medium. Spontaneously dispersed in the medium. Example, gelatin. So gelatin easily water soluble. There is a certain distinct difference between a solubility and dispersibility. Okay, solubility in যদিও বলা হয় there are two kind of dispersion. One is homogeneous, one is heterogeneous. Achieving homogeneous solution is next to impossible. Do you know why? Dispersibility is kind of different thing. It is not at all related with the solubility. Okay, water and ethanol is soluble with each other, yes or no?
Yes, sir.
Yes, sir. Ethanol is soluble in water.
Water and ethanol makes a isotropic mixture, like due to the hydrogen.
That is different issue. It is soluble in water. It is
Yes, sir,
soluble
yes,
in water.
Yes, sir.
Yes, ethanol is soluble in water.
How it is being soluble? Which factor governs that it is soluble in water? That is What is that? That is solubility parameter. If the solid, why it is being soluble? Because the solubility parameter of water and ethanol are very close to each other. That is why it is being soluble with each other. But water is not soluble in toluene. Okay, polar, non-polar takes these things. Only thing is that the solubility parameter are way apart. The water and this toluene, the parameters are way apart. That's why it is not soluble. It forms and the phase angle differs, and it does not soluble with each other. So what I was talking about, this homogeneity is a vector. In order to achieve the homogeneous solution, homogeneous dispersion or homogeneous solution, okay, the molecular level solution dispersion is necessary, or atomic level dispersion is necessary. Is it possible to get a atomic level solution? Means, let's say salt jole gulcho tumi, noon jole gulcho. So we say it's a homogeneous solution because it's readily soluble.
Yes,
But
sir.
is it true? Is it true always?
No,
So
sir.
in order to achieve that kind of solution, your absolute temperature must be 0. It should be entropy less. So is it possible to have your atmospheric temperature absolute 0? Not possible.
Yes, sir.
So that's why homogeneity is a vector. It might be near homogeneous is possible, okay, but homogeneity is a vector. Now that is the lyophilic and lyophobic part. The lyophilic part, that is the gelatin in water, readily soluble. That gold in water, it does not disperse very easily. That is phobic colloid. Gold in water, okay. Hydrophobic or lyophobic colloids. কি করে আবার ডিসপার্স করা হয়? Generally produced by mechanical or chemical action দিয়ে সেটা ডিসপারশনে পাঠানো হয়। Okay, reversible, irreversible colloids, both things. And now the major thing, important part. Are you noting down the lectures or just listening? You can note it down also. I'm telling you, because my lecture notes are not ready yet. Once it is ready, definitely I will share with you. So term is what do you mean by coagulation? Coagulation, what do you mean coagulation? Formation of aggregates, formation of compact aggregates is the coagulation. Okay, it leads to macroscopic separation. Okay, macroscopic separation of a coagulum. আমি একটু ডিটেইলে বলি। when particle কি করে, in the solution particles comes close to each other, okay, and it touches with each other. Suppose একটা 1 মাইক্রনের স্যাম্পল আছে, সরি পার্টিকেল ডাইমেনশন 1 মাইক্রন ডায়ামিটার একটা পার্টিকেল আছে, okay. Due to natural tendency, the particles tend to bind with each other, and in the process the size of the surface area of the particle increases or decreases. When it touches with each other and its size become very large, that is when it is called coagulates. The particle coagulates or particle aggregates. Number of particles, if the number of particles aggregates with each other, is eventually its active surface area gets reduced, because it's getting larger. Your coagulants is getting larger, your aggregates is getting larger, so active site for the reaction is getting reduced. বোঝা গেল আমি কি বলতে চাইছি?
Yes, sir. Yes.
So that is coagulation. That is called coagulation. Okay. And what is flocculation? This is very important. It is one of the most important for wastewater treatment. Okay, like kind of thing, to lime soda পড়তো 10+2 level you read about the lime soda, you read about the circulation and kind of relation, microfloc, macro. মনে পড়ছে না এগুলো পুরনো জীবনে?
ইয়েস স্যার, মানে একটু ভুলে ভুলে গেছি আর কি স্যার, টার্মিনোলজি গুলো মাথায়
হ্যাঁ,
হ্যাঁ।
কিন্তু এগুলো তোমরা এইচএস এ পড়েছো। অল দিস থিংস ইউ রেড ইন এইচএস। আমরা পড়োনি মিথ্যা কথা বলবে তাহলে। That implies the formation of aggregates as mentioned. আমি খুব সিম্পল যে বলছি, আমি ডিটেইলে এখনো ঢুকছি না। And flocculation is used implying the formation or loose or open network which may or may not separate macroscopically. Difference between coagulation and flocculation. Coagulation is the formation of aggregates, as I mentioned, and it can be separated macroscopically. And the flocculation is the formation of loose or open network which may or may not be separate macroscopically. ঠিক আছে? কিছু কিছু মেটেরিয়াল ইনডিউস করা হয় টু ফ্লুইড। ধরো একটা পার্টিকেল তোমার ইজ ফ্লোটিং। আচ্ছা, আমি বাইল্যাঙ্গুয়াল হলে কারোর কোনো অসুবিধা নেই তো, প্রবলেম নেই তো? মাঝে মাঝে আমি ধরো বাংলায় বললে অসুবিধা আছে না তো? আমি ইংলিশে বলবো। ওকে, ঠিক আছে, চলো। So what I'm telling, that is sometimes, let's say, some kind of particles are being washed into a dispersing medium. Let's say water. It has a charge with it. So how the flocculets will form? So a kind of particle has to be introduced into the solution whose charge is opposite to that salt, which is means colloid, which is running around the water. If flocculets comes in close contact with each other, it forms the. So these are charged flocculets. Sometimes these charged flocculets can grow on size, and they form the charge. Okay, these are the particles that are called. Hello.
স্যার আপনার আগের পুরো ওয়ার্ডটা কিছু বোঝা গেল না, পুরো সেন্টেন্সটা স্যার এত কেটে গেল।
আরেকবার বলছি আমি। ধরো sometimes in water some kind of colloid particle is being dispersed, which is charged, maybe positively charged, maybe negatively charged. So a different polymer or maybe monomer or maybe oligomer is being added to the solution with opposite charge so that it coagulates. These are called charge coagulants. And the যেগুলো add করা হয় these are called flocculants or coagulants. To facilitate the coagulation, a different polymer or monomer has been added with opposite charge than the colloids dispersed in the medium are called coagulants or flocculants. ঠিক আছে? Last is the critical coagulation concentration. What is critical coagulation concentration? লিখে নিতে পারো, the amount of electrolyte required to induce coagulation, the amount of electrolyte required to induce coagulation depends on the valence of the counter ion in the salt. The amount of electrolyte required in induced coagulation depends upon the valence of the counter ion of the salt. Okay, the concentration of the electrolyte is known as critical coagulation concentration. The concentration of the electrolyte is known as critical coagulation concentration. দেখেছো?
Yes.
Okay, I'm sharing my screen. Let me share my screen so that you can understand properly. Internet এত স্লো কেন? দেখতে পাচ্ছ?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
আচ্ছা,
Hmm.
লেটস সে একটা 1:1 ইলেকট্রোলাইট, potassium nitrate, okay, or sodium nitrate, whatever. These are 1:1 electrolyte. Why it is 1:1? So valence is 1:1. So 1:1 electrolyte. Let's switch to one electrolyte. Example, calcium nitrate. Another is 3:1 electrolyte. It's aluminum nitrate,
Yes, sir.
right? So these are type of electrolyte. These are type. Okay. These are electrolytes. And these are CCC, mole per meter cube. CCC, what is CCC? Critical coagulation concentration. What is critical coagulation concentration? Just mentioned is the amount of electrolyte required to induce coagulation depends upon the valence of the counter ion in the salt. Okay, the concentration of the electrolyte is known as critical coagulation concentration. So এই ক্ষেত্রে ধরো এইটার ক্ষেত্রে 165 3 0.05. So what is your take on the CCC this thing? You can see the valence of counter ion is very important parameter for the coagulation of a salt. Valence of the counter is very important. A example that is the amount of counter required for the of a salt. A salt ধরে নাও silver iodide. So amount of
স্যার
counter
কথাগুলো কেটে যাচ্ছে স্যার।
বুঝতে পারছো?
স্যার মানে খুব ফ্লাকচুয়েট করছে স্যার আর কি, মানে কথাগুলো প্রচন্ড স্যার মানে কেটে 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 যাচ্ছে স্যার।
আমি জানি না কেন। এবার শুনতে পাচ্ছো তোমরা কিছু?
ইয়েস স্যার, ইয়েস স্যার, এবার ক্লিয়ার স্যার।
ওই মাঝে মাঝে কেটে যাচ্ছে, আমি কিছু করতে পারছি না, আমার নেটের সমস্যা আজকে। আচ্ছা, the amount of counter ion required for the coagulation of silver iodide, এক্ষেত্রে silver iodide salt in the following order কি হচ্ছে, কোনটা সবচেয়ে বেশি লাগছে? মনোটার বেশি লাগছে, তাহলে এ কমছে, তার চেয়ে বেশি লাগছে সি প্লাস। So valency play a critical
খুব
role.
ফ্লাকচুয়েট হচ্ছে
Valency play
স্যার, ফ্লাকচুয়েশন হচ্ছে খুব স্যার।
কি করবে বা বলো? I cannot help it. বুঝতে পারছি না তো।
স্যার আপনি স্ক্রিনটা শেয়ার করছেন হয়, ওই জন্য ইন্টারনেটটা অনেকটা কনজিউম করছে, তো ওটার জন্য মনে হয়
না না, সেটা তো হয় না, আমি তো এত বছর ধরে ক্লাস নিচ্ছি, 2 বছর ধরে। আজকে এমনি প্রবলেম হচ্ছে আজকে ইন্টারনেটে।
ইন্টারনেটে একটু প্রবলেম হচ্ছে তাহলে আজ।
ইন্টারনেটে একটু প্রবলেম হচ্ছে। আচ্ছা ঠিক আছে, আমি তাহলে স্ক্রিন শেয়ার বন্ধ করছি আমি তাহলে, হ্যাঁ। শুনতে পাচ্ছ?
ইয়েস স্যার, ইয়েস।
তাহলে আমরা কি দেখলাম? সো স্ক্রিন শেয়ারটা না করলে তো বোঝানো যাবে না, যাই হোক। So what we can see that the counter ion valency takes a major call. So যে আমার মনোভ্যালেন্টের জন্য অ্যামাউন্ট সবচেয়ে বেশি লাগছে, ওকে, কম্পেয়ার টু ডাইভ্যালেন্ট, অ্যান্ড ট্রাইভ্যালেন্টের ক্ষেত্রে সবচেয়ে কম লাগছে, যে ইলেকট্রোলাইটের কনসেন্ট্রেশন সবচেয়ে কম লাগছে ট্রাইভ্যালেন্টের ক্ষেত্রে, ওকে। This phenomena, this is governed, the effect of this valence of the counter ion can be explained by Schulz-Hardy rule. What is that Schulz-Hardy rule? The Schulz-Hardy rule that the critical coagulation concentration, CCC, varies with the inverse of the sixth power of the valence of the counter ion. বোঝা গেল?
স্যার একবার একটু রিপিট করবেন কাইন্ডলি স্যার।
সিসিসি, এই জন্যই আমি স্ক্রিনটা শেয়ার করছিলাম। The CCC varies with the sixth power of the valence of the counter. যত কাউন্টারের ভ্যালেন্সি কম হবে তত সিসিসি বেশি হবে। এই জন্য মনোভ্যালেন্টের ক্ষেত্রে সিসিসি অনেক বেশি কম্পেয়ার টু বাইভ্যালেন্ট এন্ড কম্পেয়ার টু ট্রাইভ্যালেন্ট। এটা this rule is called Schulz-Hardy rule. যদি তোমার কলওয়েট Schulz-Hardy রুলের সঙ্গে স্যাটিসফাই করে, দ্যাট কলওয়েট এক্সিস্ট, আদারওয়াইজ ইট ডাজ নট এক্সিস্ট। আমি কি বলি, আজকে নেট খুব ডিস্টার্ব করছে, শুড আই স্টপ নাও? বিকজ আদারওয়াইজ বেকার বলে চলে যাবে, তোমরা কিছু বুঝবে না।
হ্যাঁ স্যার, প্রচন্ড স্যার আটকে যাচ্ছে মানে।
হ্যাঁ স্যার, আপনি পরে
তাহলে
রিশিডিউল
আমাকে
করলে
না কারোর, আমার এই নাম্বারটা, দ্যাট ইজ অলসো হোয়াটসঅ্যাপ নাম্বার, এই নাম্বারটা কারোর ইমেল দাও, এই কারোর ইমেল, হ্যাঁ, সো দ্যাট আমি কিছু তোমাদের শেয়ার করব, তোমরা নিজেরা পড়বে, তারপর আমরা মোটামুটি সেটা হলো বুঝে যাব। কারণ এইটা এইভাবে তো এগোতে পারবে না, হঠাৎ করে দুদিন ইন্টারনেটের সমস্যা হচ্ছে, বুঝতে পারছি না। আচ্ছা, তোমরা কি ক্লাস কেউ করবে না অনলাইনে করবে?
স্যার অনলাইনে
অনলাইন ইজ বেটার স্যার, অনলাইন হলেই ভালো হয় স্যার,
বেটার।
সেটা তো বুঝতে পারছি, কিন্তু এই প্রবলেমটা যে আজকে হলো, আমার এতদিন পর হঠাৎ করে এই প্রবলেমটা হলো, যে নেটের সমস্যা, ইন্টারনেটের সমস্যা, এগুলো যখন মাঝে মাঝে হবে তখন তো খুব সমস্যা হবে, তখন কিভাবে এগোবে বলো তো? আমার তো মুশকিল লাগছে এই জন্যই। সে যাই হোক, আজকে এতটাই
স্যার,
থাক।
আপনি যখন মানে এমনি এখন যেরকম স্যার কথা বলছেন, বা আগেও স্যার যতবার মানে কাট হওয়ার পরে বলছেন, এখন কিন্তু স্যার স্মুথ ফ্লোতে শোনা যাচ্ছে। কিন্তু স্যার মানে
এবার
কোনো
আমি
একটা
স্ক্রিন
কারণে
শেয়ার করে, আমি তো আমাকে স্ক্রিন শেয়ার করেই পড়াতে হবে। এবার ধরো কোনো পাওয়ার পয়েন্ট দেখাচ্ছি, সেখানে যদি এটা প্রবলেমটা হয় তাহলে তো খুব মুশকিল। আমি আজকে
Yes,
আটকে
sir.
গেলাম এই জন্যই।
Yes, sir. Yes, sir.
ঠিক আছে, আজকের দিন ফার্স্ট দিন থাক, ওকে।
Okay, sir.
সেকেন্ড দিন থেকে আমি মোটামুটি আরেকটা শুরু করব, টার্মিনাল ভেলোসিটি, ইউ নো দ্য টার্মিনাল ভেলোসিটি এন্ড অল।
Yes, sir.
Very familiar with it, yes.
সো আমি সেখান থেকে আবার শুরু করে এবার আসল করে ঢুকবো আস্তে আস্তে। সো দিস থিং, ওকে, লেটস স্টপ ইট হিয়ার নাও। লেটস সে সুদেশনা, কন্ট্যাক্ট উইথ সুদেশনা, অ্যান্ড এই ক্লাসটা, আচ্ছা এই ক্লাসের এটাই রিপিট করে দেবো আমি পরের বারের, ওকে?
Thank you, sir. Okay, sir. Okay, sir.
ওকে, টেক কেয়ার, ওকে, বাই।
Okay, sir. Thank you, sir.
Thank you, sir.
থ্যাংক ইউ স্যার।
থ্যাংক ইউ স্যার।
Thank you, sir. Thank you, sir.
থ্যাংক ইউ স্যার।
স্যার বেরিয়ে গেল। হ্যালো 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 কুশল